Yeah, good morning all. The another important topic for entrance exam is Miller indices. Right? So already we know now. Lattice points means I am drawing the lattice. The each point in it we call it as lattice points. Just some set of lattices I am drawing. Okay, in such a way. Right? This all is a lattice space. And each point in it we call it as lattice point. You already know, in my last lecture we discussed about this, right? Now what are lattice planes? Lattice planes means if we go on joining these lattice points in such a way, see, you can also join in such a way, right? Even you can also join in such a way, okay, in such a way. See, now how to define lattice plane? See, these are parallel to each other, right? These lines which are passing through the equidistant lattice points are parallel to each other. So these lines we call it as planes. The set of parallel equidistant planes passing through the lattice points, we call it as lattice planes. What are lattice planes? The set of parallel equidistant planes passing through lattice points, we call it as lattice planes. In such a way, A, B, C, okay, D. In such a way, you can draw the lattice planes. Right? Now, the problem is how to designate a plane in the crystal. The problem is how to designate a plane in crystal. For this question, answer is given by Miller indices. Miller. Okay. So now, Miller, he gave a method to designate a plane in crystal in three smallest numbers. He said in three smallest numbers H, K, L, we can designate the plane in the crystal. These we call it as Miller indices. These smallest numbers we call it as Miller indices. Right? So Miller indices, it is defined as the three smallest possible integers which have the ratio as reciprocal, such as H is to K is equal to L, ratio as reciprocals of intercepts, the ratio of reciprocals of P, Q intercepts. The ratio of these smallest possible three integers is equal to the ratio of, or is same as the ratio of reciprocal of intercepts of plane concerned on three axes. Now, if you want to understand this definition, if we go for the procedure, easily we can understand this definition of Miller indices. First, let us complete the procedure and again I will define what are Miller indices. So, the procedure means X, Y, Z. Right? I am taking a object in such a way, O, A, B. Let the intercept of this object on x-axis OB, let it be P. On y-axis OA, let it be Q. On z-axis, some OC, this one, let it be r. You let us keep it as, sorry, the intercept on x-axis, y-axis and z-axis is p, q, r. Right? Now first we have to determine the intercepts. That intercepts are p, q, r. Next we will write their reciprocals. 1 by p, 1 by q, 1 by r. Their reciprocals. Okay. Now next, after that we will determine the smallest possible integer. We will determine the smallest possible integer. Let it be HKL. And the ratio of this smallest possible integers is equal to the reciprocal of these, same as ratio of reciprocal of these intercepts. Then how to find this smallest possible integer? Let us take the example. Okay. Let 2, 3, 4 be. Listen carefully. This is most important for your entrance exam. 2, 3, 4 be the intercepts. Right? That is, we are taking p equal to 2, q equal to 3 and r equal to 4. Right? Now next we will write the reciprocal of these intercepts. 1 by 2, 1 by 3, 1 by 4. Next we have to write the LCM. What happens? What will be the LCM? 2 3s are 6. Now LCM. Let us determine LCM. 2, 1, 3, 2. Right? 2, 1, 3, 1. 3 2s are 6. 6 2s are 12. So LCM is 12. Okay. We got LCM as 12. Now multiply these with LCM. 2 6 are 12. 3 4s are 12. 4 3s are 12. Right? Now this smallest possible integer we call it as Miller indices. So in such a way we got Miller indices. Okay, in such a way we will determine Miller indices. So what are Miller indices? This is small ratio of this smallest possible 3 integers is equal to the ratio of reciprocal of intercepts taken on that 3 plane crystallographic axes. That we call it as Miller indices. Okay. Now let us take some more examples, 1 or 2 examples to find the Miller indices of planes. Okay. Then we took one particular plane in such a way. Then how to determine the Miller indices of planes? Now he may ask x-axis, y-axis, z-axis. He will shade some part. He may ask to find the Miller indices of some b, f, g, c. Okay. In such a way we took E, F, G, H. Now he may ask to find the Miller indices of this shaded part of plane. Then how he will calculate? How means, here we have to, as usual, first we have to find the intercept. Okay, and before finding the intercept, we have to remember that when force is parallel to the axis, the intercept value is infinity. Okay, now I am considering the face CGFB. Okay, this face cuts x-axis at point F, and this face is parallel to Y and Z. This cuts x-axis at point F and parallel to Y and Z. Parallel means what I said, infinity. So now the intercepts becomes at x-axis 1, y-axis parallel, z-axis parallel, so infinity. Then we will write the reciprocals. 1 by 1 is to 1 by infinity is to 1 by infinity. 1 by infinity, what it becomes? 0. So what it becomes? 1 is to 0 is to 0. So what will be the Miller indices? 1, 0, 0. Miller indices for this face will be 1, 0, 0. Now let us take another example just for your practice, how to find the Miller indices in case of planes. So I am taking another example. This is most important for not only for the MSc entrance exam but also for your B.Sc physics, for both. This is important. X, Y, Z. Okay. Now in such a way shaded part he gave. Now he is asking to find the Miller indices. It is now here this face cuts z-axis at some point you think as A, B, C, D at A, and parallel to Y and x-axis. So what will be the Miller indices? Now first intercepts infinity, infinity, and here 1. Reciprocals 1 by infinity is to 1 by infinity is to 1 by 1. So 0, 0, 1. So 0, 0, 1 becomes Miller indices. Now lastly let us take another example in such a way. We are taking a plane X, Y, Z. Now how is the plane means in such a way? The shaded part. Now see, this shaded part is cutting X, Y, Z. So intercepts are 1, 1, 1. So by this procedure Miller indices 1, 1, 1. Miller indices 1, 1, 1. In such a way we will find the Miller indices in case of planes, and in such a way we will find the Miller indices for such a integers. So first we will find the intercepts, reciprocal, LCM, multiply this with that LCM value, we will get Miller indices. So this is about the Miller indices, the most important topic for MSc entrance exam. Thank you.